All right, so today I'm going to go through how to divide radicals. Radicals is a fancy word for square root, so if you see radical, you just think root. And there's two main rules when dividing. First thing is all radicals must be simplified, so if the number could be made smaller, you need to make it smaller. And the second rule is no radical can end the problem in the denominator. So in this case here, we have a root 5 on the bottom, so we have to get rid of that somehow. For this first one here, if we ever have a radical on the top and bottom like this, we're allowed to use the quotient rule. And all the quotient rule is if you have the root of A divided by the root of B, it's going to be the same thing as the root of A over B. All this n means here is whatever root you're using, just stay consistent. So if it's the square root, keep using the square root. If it's the cubed root, keep using the cubed root. And even though this rule is a bunch of letters, it's actually quite easy with numbers. In this case here, if we just look at the roots, it's root 160 over root 5. So we would rewrite that as root 160 divided by 5. All we did was go from having two roots to one root. In addition, the 12 and 2 here on the outside could just stay on the outside. And when you're working with these numbers, you get in the habit of treating the inside and the outside numbers kind of separately. There's ways to move them back and forth, but for the most part, they don't really interact at all. So if we just look at the outside here, we have 12 over 2. Well, 12 divided by 2, that's just the same thing as 6. Inside the square root, we have 160 over 5. If we put that in our calculator, 160 divided by 5 is going to get us 32. The second thing we have to check for is, are the radicals simplified? There's a couple ways to do this, but one way I like to do it is you make the factor tree. So if we start with 32, you could break that down into 8 and 4. 8 goes to 2 and 4, and then both these 4s go to 2 and 2. Now at the end, you can make two different pairs of 2. So that means you're allowed to bring two 2s to join the 6 on the outside. And we have this 2 left over here, so this 2 stays on the inside. Now we could multiply these numbers here on the outside. 6 times 2 times 2 gets us 24. And well, the square root of 2 is just going to stay as the square root of 2, giving us a final answer of 24 times the square root of 2. Now this next example is the same thing, just it uses letters. But we have two radicals here. So let's combine them into one radical. Make it radical x cubed times y to the 9th over x squared times y to the 5th. Now once we do this, we could look to simplify the letters. If you remember when you have a letter on top and a letter on bottom, to simplify it, what you could do is just subtract the exponents. Like x to the 5th over x cubed would be 5 minus 3 gets us x squared. It's the same thing here even with multiple letters. You just look at the x's and the y's separately. So for the x's here, x cubed over x squared is just x to the 1st. You don't need to put that 1, I like to put it though. And y to the 9th over y to the 5th is going to be y to the 4th. And now you have to simplify the resulting radical. So this is the thing where you divide the exponent by the root. So in this case here, it's a square root. So we could take the exponents and divide it by 2. So 1 divided by 2 is 0, remainder 1. And for the y, 4 divided by 2 is 2, remainder 0. So whatever you were able to divide out, you could move to the outside. So there's nothing for the x, so we can't move the x outside. But for the y, we have a 2 there. So you can put a y to the 2nd power on the outside. The remainders are what stay on the inside. So for the x, we had a remainder of 1. So we're going to keep that x to the 1st on the inside. The y had no remainder though, so it comes out evenly. And our final answer is y squared times the square root of x. Now this third problem is a little bit weird. It already starts combined, but 40 over 27, this doesn't simplify at all. So if we try to simplify this radical, it's just not going to work. So what we actually have to do here is kind of the reverse of the quotient rule. So we can make this the cubed root of 40 over the cubed root of 27. Now the reason this works out so nicely is the 27 here is a perfect cubed. 3 cubed is 27, meaning the cubed root of 27 is just 3. So we have the cubed root of 40 over 3. And all we have to do for this problem now is check to see if the 40 can be broken down. So for 42, things that go into 40 are 4 and 10. The 4 goes down to 2 and 2. And the 10 goes to 2 and 5. So when this is all said and done, we have 3 2's here. Remember, it's a cubed root, so we're looking for triples there. So we're allowed to bring that 2 to the outside. And this 5 here, my handwriting is not the best, but the 5 stays on the inside. So it'd be 2 times the cubed root of 5 over 3. And the radical simplified, and there's no radical on the bottom, so we're done with this one. So up till now, every time we wanted to get a radical out of the denominator, it kind of worked itself out. But there's some problems like here, 3 over the 2 times root 5, where it doesn't just work out, and you kind of need to know this trick to get rid of it. So if you ever have a square root on the bottom and you don't know how to get rid of it, what you're allowed to do is multiply the top and bottom by that square root. Now the square root of 5 over the square root of 5 is the same thing as 1. And if you multiply something times 1, you don't change that number at all. So as long as we multiply the same thing in the top and bottom, we're not going to change the number at all. But okay, why would you want to do this? Well, let's just go through and do it, kind of see what happens. The top, 3 times root 5 is going to give us 3 times root 5. One's outside, one's inside, so you can't combine them at all. The bottom, we have a 2 here. Now root 5 times root 5, we're allowed to write as root 25. And the square root of 25, well, that's just 5. So just like that, we went from having a square root in the bottom to not having a square root in the bottom. And this is always going to happen where like root 5 times root 5 is just going to turn into a 5. The square roots cancel each other out. So if you want to skip this middle step, you can, but I think it helps to kind of see what's happening. But the top is 3 root 5 and the bottom 2 times 5, well, that's just 10. So our final answer is 3 root 5 over 10. The second one looks a lot worse, but it's kind of the same thing. You just multiply the top and the bottom by the square root of 2. So now on the top here, we actually have to distribute this root 2 to both of the terms. We have that minus sign there, so we need to make sure both numbers get the root 2. So the square root of 8 times 2 is 16, and the square root of 2 times the square root of 2 is the square root of 4. And the bottom, we get that same thing. The square root of 2 times the square root of 2 is 4. And what's nice with this is these are all perfect squares. So the square root of 16 is 4, and the square root of 4 is 2. And now we can just rewrite the problem as 2 over 2, which is the same thing as 1. So if you have the square root on the bottom here, you always want to multiply that square root on the top and bottom. Where it gets a little bit trickier is when you have a binomial on the bottom. So what the binomial means is you have a plus or a minus sign. So it's not just like root 2, it's 4 plus root 2. So when that happens, we need to use something called the conjugate. This is a term you might be familiar with, but essentially all it is you change whatever the sign is in front of the square root. So the conjugate of 4 plus root 2 is 4 minus root 2. The plus signs, you make a minus sign. The minus signs, you make a plus sign. And you multiply the top and bottom by the conjugate. Now for the top, when we do 4 times 4 minus root 2, we distribute the 4, and we get 16 minus 4 root 2. For the denominator, we have to FOIL. So it's 4 plus root 2 times 4 minus root 2. So the first term times the first term gives us 16. The two outside terms, 4 and minus root 2, are going to be minus 4 root 2. The two inside terms, root 2 and 4, are going to be plus 4 root 2. And the two last terms, root 2 times root 2, that's root 4, which is the same thing as 2. And the trick here is if you do this right, every single time, your outside and inside terms are going to cancel each other out. Minus 4 root 2 plus 4 root 2, that's just 0. So after we get rid of those, when we rewrite it, our top is 16 minus 4 times the square root of 2. And our denominator, 16 minus 2, is just 14. So this is a good answer here. The only other thing we could do is we have this 16, this 4, and this 14. All of our outside terms are even, meaning we could divide each of the outside terms by 2. And when we do that, we simplify it a bit more to 8 minus 2 root 2 over 7. And now we have our final answer.